Hi, my name is Emma, and the topic I'm going to be teaching you guys today is proving something is not differentiable. So first off, a function f is differentiable at a if f prime of a, or the derivative of a, exists. It is differentiable on an open interval a, b if it is differentiable at every number in that interval. Okay, so for a function to be differentiable, it must also be continuous. What does it mean for a function to be continuous? Well, it must follow these three rules. 1. The limit must exist. In other words, the limit as x approaches a from the left of f of x and from the right must be the same. 2. F of a must also exist. And 3. Limit as x approaches a of f of x must equal f of a. Another rule for f of x to be differentiable is that f prime of a, or the derivative, the limits of the left hand and right hand side must be equal. If a function has a corner or a kink to it, the graph of f will have no tangent at that point. Therefore, it isn't differentiable there. Also, if a function f has a vertical tangent line at x equals a, f is continuous, but it is not differentiable. So these are some graphs that show what I'm talking about. So for this one, you can see that at a, there is like a little corner or a kink, meaning that the derivative from the left and the right have two very different slopes, so therefore it is not differentiable. In this one, you can see that at a, f of x is not continuous. There is a jump discontinuity. And for this last one, you can see that at a, there is a vertical tangent line, so f of x is not differentiable there. Okay, let's get to some examples. Example 1. Where is f of x not differentiable and why? So as you can see from this graph, we see that at x equals 1, there is a jump discontinuity. So that means it is not differentiable there. At x equals 3, there is also a discontinuity because there are asymptotes. So it is not differentiable there either. And also, at x equals 5, there is a vertical tangent line. So the answer is f of x is not differentiable at x equals 1, x equals 3, and x equals 5. Example 2. Where is f of x not differentiable and why? As you can see, we have a piecewise function. So when x is less than -1, f of x equals 5. When x is in between -1 and 6, f of x is 2x plus 7. And when x is greater than 6, f of x equals 5x squared minus 4x. So we start off by finding the limit as x approaches -1 of both sides. So from the left, f of x approaches 5. And from the right, if you plug in -1 to 2x plus 7, you also get 5. You do the same thing with x equals 6. So from the left side, 2x plus 7 equals 19. And from the right side, 5x squared minus 4x, you get 156. So from that, we can already see that at x equals 6, f of x is not differentiable because there is a jump discontinuity. So if we go back to x equals -1, it is continuous because f of x equals 5 from the left and the right, except if you graph f of x along with its derivative, you can see that at here, it might be continuous, but when you graph the derivative, there is a jump because there is a difference in slope. And of course, there's a discontinuity here, so at here, the derivative is very different. So the conclusion is, because the derivative at 5 is 0, and the derivative of 2x plus 7 is 2, the derivative of 5x squared minus 4x is 10x minus 4. So f of x is not differentiable at x equals 1 also, because the left and right hand limits of f prime of x are not equal. Okay, example 3. F of x equals absolute value of x squared minus 25 all over x plus 5. Prove that x is not differentiable at x equals 5 using the definition of a derivative. So, the definition of a derivative is this. Limit as x approaches a, f of x minus f of a over x minus a. So first, let's split this into a piecewise function. So when x is less than -5, we can see that f of x equals x minus 5 times x plus 5 over x plus 5. So you can simplify that to just x minus 5. When x is in between negative 5 and 5, f of x is the negative of absolute value of x squared minus 25. So we can simplify that to negative times x minus 5. So then when x is greater than 5, we can see that it is x squared minus 25 over x plus 5. So it simplifies to x minus 5. So after you've changed it to a piecewise function, you can use the definition of a derivative, and you can see f of x minus f of 5 over x minus 5. As limit approaches 5, from the left side, you can see it's negative x minus 5 minus 0, which is what f of x equals when x is 5 over x minus 5, and you can cross that out, and you get negative 1. And then limit as x approaches 5 from the right, if you use the definition of a derivative, you get x minus 5 minus 0 over x minus 5, which is positive 1. So using the definition of a derivative, we can conclude that the left-hand and right-hand limits as x approaches 5 are not equal. Therefore, f of x is not differentiable at x equals 5. Example 4. If f of x is a piecewise function, where if x is less than negative 3, f of x equals 6x plus 2. If x is in between negative 3 and 4, f of x is equal to 2mx minus b. And if x is greater than 4, f of x equals c. Find values of m and b, so f of x is differentiable at x equals negative 3. What must c then equal for f of x to be continuous at x equals 4? And keep in mind that m, b, and c are all constants. So first off, you can conclude that if f of x is going to be differentiable at x equals negative 3, then 6x plus 2 must equal 2mx minus b. So the derivative of 6x plus 2 is 6. So 2m must equal 6. Because if m and b are both constants, the derivative of 2mx minus b is 2m. So if 2m equals 6, then m must equal 3. So 6x plus 2 must equal 2mx minus b. So at x equals negative 3, you can see that it equals negative 16. That must equal 2 times m, which is 3, times x, which is negative 3, minus b. So because of this, we now know that b must equal negative 2. So to make f of x continuous at x equals 4, 2mx minus b must equal c. So we now know m and b. So we can conclude that 6x plus 2 must equal c at x equals 4. So if you plug in 4, you get that 6x plus 2 at 4 would be 26. So c must equal 26. Example 5. Sketch a graph f that is not differentiable at x equals negative 3, x equals 1, and x equals 5 on the domain negative 5 to 6. So answers may vary, obviously, as there are many possibilities that would make f of x not differentiable at x equals a, which in this case, a equals negative 3, 1, and 5. So as long as you do one of these, you are good. At x equals negative 3, x equals 1, and x equals 5. So either draw a vertical asymptote, which would make it discontinuous. You could draw a vertical tangent line, which would also make it undifferentiable. You could make a corner or a kink, which if you draw the derivative at those points, you'll see that the slopes will be very different. Or you could do like a jump discontinuity. So, and also make sure that f of x must be on the domain negative 5 to 6. So here's an example of what you could do. So at x equals negative 3, I drew a vertical tangent. At x equals 1, I drew a vertical asymptote. And at x equals 5, I drew a jump discontinuity. Thanks for watching. If you guys still want some extra practice, you guys can check out the worksheet, and there is a key along with it so you guys can check your answers. Thanks again.